Okay, in this video I still want to go ahead and talk about the problem 75 one more time here. And I've gone through it mathematically, but I kind of want to go through it in a very simple, logical way. And that is to say this, that since in 2000 women's wages were 80% of men's wages, so I'll say that's 0.8. They started out being 68%. And so that means that they increased 0.12 or 12% in 10 years. So if they increase 12% in 10 years, then every year we just divide that 12% by 10 and they would go up 0.012 or 1.2% every year. So if there's an increase of 1.2% every year, then from 1990 to 2004, it's 14 years. So let's multiply. 14 times 1.2 gives you 16.8. And that means that women's wages increased 16.8% of men's wages in those 14 years. Finally, they started out being 68% of men's wages and they increased 16.8% of men's wages, so that gives you 84.8% of men's wages now. So if you notice the way I did that there, I really did it with a lot less algebra and a lot less arithmetic than I did previously. So hopefully those two ways together make this a little bit clearer. You don't have to do it the algebraic way in this case. It's just asking you for the number, and actually it's probably more important that you're able to reason through this. They started out being 68% of men's wages. After 10 years they were 80% of men's wages. That means that they increased 12% in 10 years. If you take the 12% and divide it by 10, that means they increased 1.2% every year. And a linear increase means that it's just going to be the same rate of increase from year to year. So if they increase 1.2% each year, and we want to find out in 2004 where they are, well, 2004 is 14 years later, so 14 times 1.2% gives you 16.8% total increase. That's not what percent they are of men's wages, but how much they've increased since the beginning of the time that it was calculated in 1990. So they have an increase of 16.8 on top of they were already 68% of men's wages. So we add the 68 plus the 16.8 and we end up with 84.8% of men's wages in 2004. So I hope that's clear. Another way of looking at it, certainly a lot less complicated with a lot less variables, and probably would be a lot less confusing. And it's okay to look at it that way. I did it algebraically in case anybody would be interested. Alright, I'll go on to the next problems in the next video.